All right, then. So today is Java 2 Lesson 2. And what we're going to be talking about today is something called exceptions. So exceptions are an event that happens during a program that disrupts the flow of the program. If an exception is not caught, then the program terminates. And what I mean by caught, I will explain later. And these exceptions, they're kind of like errors in a way. It's just they're more easily dealt with in a way. So these are like some types of exceptions that you might get. So first one over here, we have arithmetic exception. And this occurs when an integer is divided by 0. And this, inside the parentheses, I have like a little note. So if you divide a double by 0, then it equals infinity. So this is mainly what happens, an arithmetic exception is mainly what happens when you divide integer by 0. And so you see here also, array index out of bounds exception. And this happens when somebody tries to use an array with indices that aren't there. So either when the index is lower than 0 or larger than array size minus 1. And this one, since you learned about arrays in Java 1, you should kind of know about. This is the only time, this is probably the first time that I specifically said the name of the exception though. This is an exception that you might get. Next one is negative array size exception, and this occurs when a created array has a negative size. And so I have an example of it in the next slide, I believe. So I'll show you what that means. And last one is called exception, and this is just all exceptions. And it's called the superclass of all exceptions. And I know that you guys don't know what superclass means yet, but if you're here for Java 3, I'll explain about it. And so you'll know about it later. All you have to know right now is that it includes all exceptions. So, like I said, I have some examples. So first one, arithmetic exception, you can see here that if you do something like this, where you divide a number by 0, then you'll get an arithmetic exception. And the next one, which is array index out of bounds exception, you can see that if I have an array of 5 and I want to see a -1 index here, then I'm going to get an array index out of bounds exception. And this last one, which is the negative array size exception, if you put something like this, then you'll get one of these. And that's what I meant by negative array size, meaning that if you put a negative number inside these square brackets, then you'll get a negative array size exception.
Wait, I have a question. Didn't you say that if you do -1 as an index for array, that just means the last item?
No, that's never said that before. No.
Really?
Yeah. So, just like a refresher then. So, for example, if I have an array size of 5, then the indices go from 0 to 4. Like, you never use -1 as an index. But I meant like, that might have been like the problem with the wording. What I meant by the like array length -1, it just means that the biggest index basically on the previous slide. But yeah, these are examples of the exceptions. So this is the try and catch block. And so there are ways to handle exceptions so that they don't stop the program. And that's what I meant by the catching, like catching an exception. This is a way to catch it so that it doesn't stop the program. And general implementation of try and catch block. And this is the following. So how this works is that, so for example, if you ever didn't know if a piece of code would cause an exception, you could put it inside a try block. And then what this catch block does is that right here where it says exception, you put whatever exception you want to try to catch. And then this E is like a variable name, so you can put whatever here. And then inside here, you put some code that would happen if the exception did happen in this code. So, for example, if the code that you put in the try block did cause an exception, and if this exception matched the one that happened here, then this try block would then go to this catch block and execute the code inside here. If, for example, there was no exception here, then it would just skip over the catch block entirely and go on to the next piece of code. If an exception happened here, but it does not match what this exception here is, then it'll still cause the exception and it'll still stop the program. Yeah, this is about what I just said. And so this is, again, when I first introduced the exception that in like the types of exceptions page, this is what I meant. This is like somewhere where you can use it, which is in a try and catch block. This applies to all exceptions. So basically, if you put exception where you put the exception in the catch block, then you're basically making a large net that catches all exceptions. So whatever, if there's any exception that happens in the try block, it catches all of it. No matter what type it is, it catches all of them. Yeah, again, so like if the catch block catches the right exception, then the exception won't terminate your program unless you ask it to, which I'll go over later. Yeah, then it'll execute whatever's inside the catch block. If there's no exception, then things inside the try block is executed and the catch block is skipped over. So just an example of how a try block might work, try and catch block might work. And so you can see here, this is the example code I have. And so the output of this would be A exception. And why that is because first, when you go through the try block, it first goes to this first line and it prints out A, as it always should do. And then it goes to the next line. Then we go to the next line. And you see here that you can't do 9 divided by 0. It'd be an arithmetic exception, right? So it would cause an exception. But then since there's a catch block here, then it goes to this and tests this. And turns out it does match it. It catches arithmetic exceptions. And so it goes here and prints out exception. And then it goes on to the next piece of code. And so what you'll notice here is that it doesn't print out B at all. So how try blocks work is that once it hits an exception inside the code, it automatically goes to test the catch blocks. And it doesn't execute the rest of the code inside. And so that's why B isn't printed, and only A and exception are printed. So just some notes about try and catch blocks. So you can have multiple catch blocks after a try block to catch different exceptions, but you can't have a catch block without a try block or a try block without a catch block. And I know that's kind of like a mouthful, but it just means that you can't have one without the other. So, and next one, the try block will execute everything inside unless it reaches an exception, where it skips to the catch block, not executing the code after the exception in try block, which is basically what the slide up before showed. And again, exception will catch all exceptions no matter the type. And of course, there are more exceptions, but we'll get to them later on in both Java 2 and Java 3. So yeah, there's definitely other exceptions. We're just not going to go over all of them in here since there's some exceptions that you might not understand yet, since it has something to do with knowledge that we're going to learn in later lessons. So the finally block. Finally block is put after catch blocks, but it's completely optional to put. It's executed after try and catch blocks, and is executed no matter what happens in the try block, except if you wanted to not execute, and the code will come later for that. So the general implementation is this. So basically, this is kind of like something that always executes, no matter what happens. And even if there is an exception in the try block, it still executes if it's not caught. So yeah, that's it. That's basically all I can say on that, since it's not really complicated.
Wait, what is it used for?
It's used for, I guess, for example, if you wanted a message to always come through the like your program, even if it didn't have an exception, that's why you would use it, since it's kind of like something that always happens. Like if you didn't want to depend on your program, since you never know when you have an error in your code or an exception. So by using a finally block, it kind of just makes sure that if there's something that you really want your program to output, it always outputs it. So the exit statement. So this is what I meant by like quitting the program. And this is like the one thing that would stop your program and stop finally, sorry, not stop your program. It's not the only thing, but it's the only one way that can stop a finally block from executing. So if you type the above statement, which is the system.exit, before a finally statement, then the finally block does not execute. And this statement completely exits the program. So anything after it will also not execute. So example of how finally an exit statement might work. So over here on the left, you can see that I have in the try block an arithmetic exception. And since this catches the wrong type of exception, it completely skips it and goes to the final block, and it prints out A. So first in the output, you would see the arithmetic exception message, and then you would just see an A after it. And over here on the right, you can see that if I put a system.exit right here, before the exception happens and before the finally block, then the output would be nothing. Some more definitions: checked and unchecked exceptions. So some exceptions are called checked exceptions, which are basically exceptions that have to be either caught by a try block or method. And I haven't gone over how to catch it with a method yet, so we'll go over it later on. But right now, checked exceptions basically just think about it as being caught by a try block. And unchecked exceptions are basically when exceptions are not caught by a method or try block. Throwing exceptions. And so I know it's a lot of information. I think this is the last slide. So if you wanted to write a message while creating an exception, this is the format. So throw new, your exception name, and then a message here. So if you didn't want to write a message when you create an array, create an exception, then you would just leave this blank and not put anything in parentheses. And what this does, it just manually creates an exception that stops your program. And I guess this is a good way to see what like an exception message might look like. But yeah, so this is how you would do it. And again, you can put any exception you want in here, as long as it's an actual exception. And yeah, this part basically just summarizes what I just said. An example of having code to throwing an exception. So you can see throw a new arithmetic exception, you divide by 0. And what it would do is it would output an exception message with you divide by 0 at the end. And yeah, I think that is about it. So that would be it for this lesson for now. And in a few seconds, I'll be going over the class problems that we'll be doing for today. Okay, so this is the class problems for this week. And so just try them and make sure that you understand the knowledge pretty well. And if you have any questions, comments, or concerns, then you can put them in the comments below. But otherwise, that would be it for this lesson then.